Here we will be doing question 3 of the free response section of the BC Calculus exam in 2017. So this question gives us a graph of f prime, which is shown above, and it gives us a reference point at f of negative 2. So the first part of this question, part A, asks us to find the values of f of negative 6 and f of 5. Notice that it doesn't ask for the f prime value. We need to look for the f value. So we know that this, the graph of this f prime, we know that we must first use our reference point. So all points start with 7. So we'll start with f of negative 6 equals 7, because that's what we have right here. And then for this one, we need to subtract the integral from negative 6 to negative 2, which is the point we're looking for. And we need to take this area in here, which comes out to be 7, or so we need f prime of x dx equals 7 minus 1/2 4 times 2, which equals 3. So now to do f of 5, we start with our reference point at 7, and we add the integral from negative 2 to 5 f prime of x dx, which gives us 7 plus, just calculate this area right here, 1/2, or it would be minus 1/2 pi r squared, which is 2. 2 squared plus 1/2 3 times 2, which ends up equaling 10 minus 2 pi. So those are our two answers for part A. So now for part B, it asks on what intervals is the function f increasing? Justify your answer. So this is one of the easier questions, so we just need to basically know that this is a graph of f prime and that this gives us the derivatives, which is the slopes. And anytime a f prime is positive, that means the derivative is positive and f is increasing. So we just need to find the intervals of when it's positive, which is negative 6 to negative 2 and 2 to 5. So those are the two intervals, and it is because f prime is positive. Obviously, you could write that out more clearly. So now for part C, it says to find the absolute minimum value of f on the closed interval of negative 6 to 5 and to justify your answer. So we're going to need to find a few points here. So we know that f from part A, f of negative 6 equals 3, and that f of 5 equals 10 minus 2 pi, which is less than 3. And now we need to test the endpoints and the other important point of inflection. So to test the endpoints first, we'll find f of 2 equals f of negative 2, which is 7, which is our reference point, plus the integral from negative 2 to 2 of f prime x dx, which equals 7 minus 1/2 pi 2 squared, which equals 7 minus 2 pi. So this one's smaller than these two because this is equals about to be less than 1. And now the only other one we have to test, or no, that's the only one, because after that it goes to positive, and you know that if you add area it's going to be bigger. So because for our justification, which is asked for, because f of 2 has the most negative area, most before it goes positive. So the answer is f of 2 is where the absolute minimum is. And now for D, it asks, for each of f double prime negative 5 and f double prime of 3, find the value and explain why it does not exist. So for the first one, we know that f double prime of a function is just the derivative of the derivative. So if we look for, erase this, look for negative 5, which is right there. At that point, the slope right there is negative 1/2. So that is the value. Now for f double prime of 3, we look on the graph, and it's right here. Now at this point, there's a corner, so the slopes are different approaching it from either side. So it does not exist. Equals DNE because f double prime of x is not differentiable at x equals 3. And that is all of it.